Hi everybody. Before we get into lesson 4, I just want to have a quick talk about notation. So we're used to referring to our function as either y or f of x, and I think we've worked out by now that if the function is described as y, the derivative is usually called y dash, and if the function is called f of x, the derivative is called f dash of x. Now, these are interchangeable, so if the function is called y, you can call the derivative f dash of x, but generally speaking, you stick with the notation that the question has used. There's two extra pieces of notation for the derivative. The first one is called the Leibniz notation, and it is that the derivative is the limit as delta approaches 0 of delta y on delta x. Now, what does that mean? Well, delta in maths and in science means difference or the change, and so we're simply talking about the change in y over the change in x, and we've seen delta x represented as h, so the limit as the difference gets closer and closer to 0. This is otherwise known as, more simply, dy dx. It's not a fraction. You can't cancel anything. It doesn't behave like a fraction. But it is simply the change in y with respect to, so WRT stands for with respect to the change in x, which, if you think about it, the change in y is effectively the rise and the change in x is effectively the run. So there's a very, very, very strong link between dy dx and rise over run. So you've got a more formal definition in your booklets there, that the derivative function f dash of x is equal to the limit as delta x approaches 0 of delta y on delta x, or dy dx. Now, I forgot to put the x in there, didn't I? Delta x, the change in x approaching 0. Okay, so having a look at example 1. Example 1 is asking you to find the graph, find f1 and f dash of 1. So f of 1 is simply the value of the function when x equals 1. So if you draw down and across, you can see that the value of the function there is approximately negative 0.95. So f of 1 is negative 0.95. F dash of 1 means the derivative at 1 or the slope of the tangent at 1. So we can draw a tangent and do rise over run. I've estimated a tangent here, and by estimation again, this point is 0.5, negative 1.2, and this point is 1.2, negative 0.8. And if you do rise over run with that, you'll end up with f dash of 1 equals negative 1.2 minus negative 0.8 divided by 0.5 minus 1.2, which comes out to 4/7. So a rise of 4 basically and a run of 7. For the next one, f of 2, here it is here. So the value of the function when f is 2 is approximately 0.6. So f of 2 equals 0.6. And the slope at 2, as best we can estimate by eye, the slope at 2 appears to be horizontal. So the derivative at 2 is 0. The slope of the tangent at 2 is 0. Same with f of 3. By estimation, the tangent at the point 3 is at 3, negative 0.95. And again, by estimation, the slope of the tangent can be calculated using the points 2.6, negative 0.6, and 3.6, negative 1.6, and you should be able to convince yourself that the slope of that is in fact negative 1, which means f dash of 3 is negative 1. There's a couple of other features of this graph that we need to consider. The first one is the value of the function. So the way that we do that is by a sign diagram. So here I'm going to draw a sign diagram for the function. So here's x, and I'm actually going to specify that the values on the top are for f of x for reasons that will become obvious in a minute. So our first critical point is 0.5. The next is 1.5, 2.5, and 3.5. I've barely left myself enough room. To the left of this point here, the value of the function is positive. Between these 2 points, the value is negative. Between 1.5 and 2.5, it's positive. Between 2.5 and 3.5, it's negative, and then it's positive for the remainder of the function. Now, the second sign diagram that we can draw is actually a sign diagram for the slope. And so we're going to do a sign diagram of whether the slope is positive or negative, as in whether it's sloping upwards or downwards, if I can get a nice straight line. There we go. So this time we're not considering whether the function is above or below the x-axis. We're considering whether the graph is sloping downwards, like it is in this section here, or whether it is sloping upwards, like it is in this section here. So you can see that we've got these upwards and downwards sloping sections, and the slope for the upward sloping section is positive and the slope for the downward sloping section is negative. In between, and I'll mark these points in pink, in between, the slope is neither positive nor negative. The slope is in fact 0, and they are our critical points on the sign diagram for our derivative. So this time I put x here to show that I'm talking about x coordinates, but I write f dash of x to show that I'm talking about the slope of the derivative. So our critical point here, if we read off our graph, is approximately 0.9. The point in the middle there is 2, and this point here is approximately 3.1. And you can see in the section marked in yellow to the left of 0.9, the graph is sloping downwards, so it gets a minus sign. It doesn't matter whether it's above or below the x-axis, it's whether it's sloping downwards, sloping upwards, or neither. It's neither sloping down or nor up at 0.9, but between 0.9 and 2, it's sloping upwards. Between 2 and 3.1, it's sloping downwards. And between 3.1 up to infinity, it is sloping upwards. So there you've got the sign diagram for not only the function, but the derivative of the function as well.